Okay, so we've already started our foldable and done the first two. Right now we're on opposite rays. So those are rays that share a common endpoint and they continue infinitely in opposite directions. When you name them, notice EF, okay? EF, the arrow is going from left to right. In the picture, is EF going from left to right? No, isn't the arrow pointed in the opposite direction? Okay, that doesn't matter when you're naming it. When you're naming it, it's always going to be what first? Yep, let's say it all together. What's going to be first? The end point. Okay, so what's going to go first? Okay, we'll try it again. What's going to go first? The end point. Okay, so that's really important. You can see that we put a little star on that and the one above it. Okay, so EF and EG are your opposite rays, and E is the common endpoint for that one. Okay, now we're going to go up to the next one, which is a line. So a line has no thickness. Okay, it's an object with no thickness that extends indefinitely in two directions. And if you look at the illustration for the line looks exactly like the illustration for the opposite rays. So even in that illustration that we have there, we have opposite rays. Okay, I want you to think about what we would call those opposite rays. Okay, and Kaden, what do you think? If you were to name a pair of opposite rays from that new illustration for the line, what would those be called? Yeah, yeah, opposite rays.
Letters?
Mm-hmm.
C,
So remember when you say the name of the opposite ray, you always have to start with what?
so DC, D.
Yes. Yep. Okay, so it'd be DC and DE. And then when you're labeling those, again, you just want to make sure that you have that arrow, okay, the one-sided arrow. Now for the line, Danny, what's the symbol that we have for the line? How would you describe that? Okay. Okay, yeah, so it is going to be a straight line, but it has those two arrows on the end. Now, I put any name that you could call that. So you can see there's many different names for it. You would just have to pick one of those names if you had a diagram and it said, oh, find a line in the diagram. So CD and DC, those are both lines. It doesn't matter the order. Same thing with CE and EC. Okay, that doesn't matter for this. It matters for the ray because in the ray you have one arrow and one endpoint. Another way you'll see a line named is with an italicized letter. So like for that one, it's a fancy L. So you could either call that line L or CD, DC, CE, BC, DE, or ED. Now, any of those lines that we just named, those could also be what? They could also be rays. That's why the way that you notate it is going to be really important because that's going to set those two apart. Okay, and then the next thing we have is a line segment. So in the illustration, you can see that the line segment is going to have two endpoints, and it doesn't matter if you call it AB or BA. You do use those 2 points to name the segment. And again, notice the difference in the naming. So if it's just a segment, Cameron, what do we leave off of this? What's the difference between our line segment and our line notation? Right, good. Okay, so the line segment has no arrows. Okay, so it's just like that straight bar at the top. So if it's a line segment, it's part of the line that consists of 2 endpoints and all the points in between them. You may have heard this before, but there are how many points on a line? An infinite amount, right? So even though we can only see A and B, we know there's an infinite amount of points that are in between them. But yeah, so between any 2 points is one line, and we'll talk about it. Okay, do you guys need any more time with the second one? Okay, so when we're doing notes, I'll actually ask you that a lot. If you need any more time. If you don't need any more time, you don't have to say anything, or you can nod. If you do need more time, make sure you say yes, so that I know to keep that up for you. Okay, so if you don't need more time, don't say anything. That way if somebody does, then what I hear is, yes, please give me more time. Okay, now the next thing we're looking at is a plane. So generally the shape of the plane kind of looks like a slanted square or a parallelogram. Have you guys heard of a parallelogram before? Bless you. Okay, so a plane is a flat surface that has no thickness, and that continues infinitely in all directions. And then I put a little something in star notations there, and that's that you need 3 points to make a plane. In a little bit, we'll actually learn about a postulate that talks about 3 points in a plane and what happens. Now, sometimes with a plane, you'll have like a fancy letter. Like in this case, our fancy letter is B, and you would call that plane plane B, or you can pick any 3 points in the plane. Okay, so the 3 points we have in our plane are X, Y, and Z, so we would just call that plane X, Y, Z. So the naming is either a capital script letter or 3 points that are not on a line in the plane. Okay, so X, Y, and Z are not on a line. That's why we can use those 3. Okay, so now I want you to go to your notebook that you're using as your interactive notebook. Okay, if you don't have your notebook yet, that's okay. You can also attach these to a piece of paper. Okay, so before you glue anything down, at the top of your first just gonna do this one for right this minute.
Where are we supposed to add it?
1.1, understanding points, lines, and planes. And if you missed any of those pictures on the front, you can go ahead and put those in. And then the next thing that we're gonna do is the foldable that says on it collinear, non-collinear, coplanar, and non-coplanar. Okay, do not glue this one down yet because we have found that it is a lot easier to sure that you put the label on there. So it's really important when you label a segment, you have the proper notation. You can call this either UV or VU, okay? And really, this could be V and U too, as well. Okay, opposite rays with common endpoint Q. I called them P and R. Doesn't matter what you called it. What does matter is that you have QP with the arrow going left to right. Okay, the arrow goes left to right. So Q's in the middle, Q's the endpoint. Rays always start with what? What do rays always start with? Their endpoint. Okay, and then the last one is a ray with an endpoint M that contains N. There's no other way that you can label it. It has to be MN, but your picture does not have to look exactly like mine. So you could have it going in the other direction. It's just important that the side with the arrow goes with what letter? The arrow is going to go with N. Yep. And then the M point goes with M. Okay. So feel free if you need to copy any one of my pictures that you have that. Okay, so you guys just wrote down the definition for collinear and non-collinear. So if they are collinear, they lie on the same line. The example is M, N, and O are collinear. Those are on the same line. And for non-collinear, they do not lie on the same line. So M, N, and O are not collinear or non-collinear. You can say either one. Based on that definition, can anybody tell me what they think coplanar means? If collinear means that points lie on the same line, coplanar probably means what? Points lie on the same line. Okay, so if points are coplanar, they are points that lie on the same plane. An example would be if you had X, Y, and Z. And I do want to point out, we'll go over this in the postulate, but we can see clearly that X, Y, and Z are on a plane, a picture of a plane. They don't necessarily have to have that picture in order for them to be coplanar. Okay, and we will talk about that. If they are not coplanar, they do not lie on the same plane. And I gave you a few examples. A, B, and C are non-coplanar. B, C, and D are non-coplanar. And then we are going to talk about some postulates that are going to go with these definitions. Okay, so what I need you to do is I need you to analyze your notebook or your piece of paper. Okay, I put my foldable facing vertically, and I'll show you what that looks like. But some of ours are not going to fit that way. Okay, so whatever way yours fits on the page is perfectly fine. Okay, don't put it underneath what we just did. So turn to the new page. Okay, so it'll be the page right next to the one we just wrote our example on. Okay, so this is our first page. This was the back of the first page. And now we are at our second page. Okay, if you can paste it like this up top and you have room to put this at the bottom, that's fine. Not all of us Okay, so postulates are going to be rules that are accepted as true, and theorems must be proven. So what we're going to work with today are the postulates, and the postulates tell you the first one: through any 2 points, there is exactly one line. Through any 3 non-collinear points, there is exactly one plane that contains them. And if 2 points lie in a plane, then the line containing those 2 points lies in a plane as well. So with the first postulate, what that means is any 2 points are going to make up a line. You don't even have to physically see the line in between them. You can always draw a line in between them. It's the same thing with the 3 non-collinear points. As long as they're non-collinear, there's going to be a plane that contains them. And then for the last one, if 2 points lie in a plane, the line that contains those also has to lie in a plane. So what we're going to do is we're going to finish up part of our foldables for 1.1, but you are just going to do your book work only for homework. And if you want to take a picture of the book work, you can do that. It will also be on Google Classroom. If you missed anything from your foldable, I make videos, so I will post a link in your Google Classroom for the video so you can go back and watch